Let's go through LeetCode 2398, maximum number of robots within budget. So for this question, it gave us integer array charge times in the integer array run cost and also a long budget. So it asks within these kind of budgets, what's the maximum number of consecutive robots you can run? Um, so we are trying to find the longest subarray, which has a budget, has a expense, which is smaller equal to this kind of formula. So we'll say we're trying to find a subarray, for example, and which have the longest length and the left, right. And here there is a maximal value, right? The max of this charge time. And also k multiple plus k multiplied by this kind of uh, sum, sum of the running cost. So if we brute force, right, we also need to find a maximal from this kind of left to right. The time complexity will be if we brute force left to right, and also need a max that will be ON3, right? Even we use some kind of heap, right? Um, use heap, of course, and we here that is two pointer, right? Because left and right have for some conditions, if it is uh, doesn't exist, we need to move left pointer. We keep in iterate right pointer. Um, and when we move the left pointer, there has some kind of things being moved out, right? So we can use a heap, but heap that will also be involved in time complexity, right? So we should do. We know we're not asking the top k max charge time. We just want to find the max, right? Just one value. So we know for a sliding window to find the max, min or max, we can use a monotonic deck. So for monotonic deck, there are three kind of steps. One is we add a data from the right and pull those kind of useless data, right? For example, some kind of condition, uh, those will not be better than current one, just pull them out. Uh, and then add a current index to our data structure. This is one of the steps that is pull right, right? And another step is for the left um, part, it's being controlled from for some condition, for example, some kind of index. Here for this question, it is the budget, right? So we pull left, pull or in Java that is pull first. Those kind of index from this data structure, which need to satisfy the budget's condition, right? And the third step is to do the processing. Sometimes the order may not be strictly like this. For example, we want to find the max does not include current index, right? Then we may need a step two be first step, and then do local comparison, local processing, and then the last step will be pull right and add this one, right? So sometimes we want to look at the previous min max in window doesn't include current one, right? In that case, this step one will be moved to the left to the step three. But for this one, it is kind of straightforward. We just add pull those kind of useless index from the right and add current index, and then control by the window size pull from the left, and then process, right? So let's write code for this. Um, we need a deck to store those kind of index. New array deck. So we know let's have n equals, it said that the charge time and the run cost should be the same length. Uh, charge times vector length. And we have a left point here um, to count how many, because what we want is the maximal number, right? So we can use a left pointer, right pointer here. And the result equals, this will be the counts. So it will be right minus left um, plus one, right? If we locally there is a result, right plus, we'll need to find the maximum of this. And we need expense, because this expense, we don't need to, we want it not more than budget, right? So what we do now is that for our right point for int right equals 0, right smaller than n, right plus, right? So because current index is included, because this max charge time is is include the current one, right? So it's not asking the previous one. So we need add a current one. But before we add a current one, we need to check in our deck those kind of useless data, right? So if this is empty and charge, because we need to find the maximum charge time, right? Charge times. So if this kind of deck pick last, this kind of charge time is smaller equal to then those right index charge times. That means those indexes in the deck, they will never be the max, right? Which can have deck for last. And so for this one, after this, we'll add a current index, the right one. Add last, right. So because right is added to our current window. So we'll say this formula, we need the sum of the running cost, right? So this expense, let's call sum. Let's call expense, right? This is sum of the running cost expense. Let's still call expense. Okay. Let's should plus equal to, but this expense will make sure it is this part, right? What we compare, we should still compare the maximal plus k multiplied by this expense. Should add equal to running cost, right? So this will be first step, step one. And step two is by checking this kind of cost, right? This will be the real expense, right? A moment ago, that is just sum. Let's call this one to be sum, right? Will be better. Sum. So we call this formula expense, right? So we'll say, wow, this kind of expense is, if this is greater than budget, right? The kind of deck is not empty. And so charge times. So we'll see what is the max. Max will be deck pick first, right? The charge times of deck pick first, and multiple by k plus this kind of formula k multiple by this k is what is right minus left plus one, right? And multiple by sum. If this one is greater than budget, then we need to shrink our left pointer, right? No matter so left pointer will move, right? So that way means our sum should minus equal to running cost left, right? And left plus. In the meanwhile, we may need to pull some of data from the left, right? Because this kind of slide window. But since that this left may be pulled from this side, right? So it is possible the left already been pulled, right? But here the thing that we this while is control two things. One is the deck left side, and another is this two pointer right and left pointer, two pointers index, right? So this one, no matter it will always minus from our sum window, right? But whether we need to pull from the left, we need to check whether this left is still in the deck. So I say if deck dot peak first equals left, then we're going to have a deck dot pull first. Right? Because this left may possibly be pulled from the right side. Then here we are going to, because the left right pointer, after we move our right pointer, we use this kind of condition to shrink our left pointer, right? So we have a local result. So we are going to update our max result to be right minus left plus one, right? And in the end, we return result. EQUE. Doing like this, we use a deck to get the maximum value, right? So that will be an ON time complexity, and space will also be ON, right? And let's write a Python code for this as well. We need a import from collections. Import deck. So what we do is that we need a DQ equals deck, right? And then let's have n equals the length of charge times, and we're going to have left result result and sum equals 0. Let's call sum seems that it is a preserved word. Let's call it win sum, right? This window sum is this part, right? K sum of running cost called run sum. Okay, running cost sum equals 0, 0, 0. For right in range n, then we're going to use because the max is including current index, right? So while this deck is not empty, and charge times deck dot there's no, we use -1, right, to pick. If this is smaller equal to charge times this right, means those kind of data in deck is useless. Then we'll have deck pop, and we'll always have deck up and right. So this is then we know this right include this kind of RC sum, which is plus equal to running cost, right? And we are moving our left pointer is that while this kind of expense is is we exceed those kind of budget, right? So and so what's the maximum value? So that is charge times DQ 0, right? Plus, so right minus left plus 1 multiplied by win RC sum. If this is greater than budget, then we need to have move our left pointer, right? So move left pointer, our this kind of window should minus left. Also, line 15 and 16, we cannot change the order, right? And here we need to check if the left pointer is still in the deck. If it's still in the deck, we also need to pop left. Yeah. So if deck deck 0 equals left, then we're going to deck pop left. And after this while loop, we use have a local result equals max result and the right minus left plus 1. And in the end, we return result